Welcome to One Chemistry. In this video, we are going to see geometrical isomers. We will use 3D animation for complete understanding and 10 fully solved examples. Stay tuned. What is inside this video? We will see what is geometrical isomer, the isomer in linear, trigonal planar, tetrahedral, square planar, octahedral system. We will see all the possibilities and isomers. More importantly, we are going to see 10 fully solved examples related to geometrical isomers from various examinations. Here I given library of geometrical isomers for your reference. For ML2 system, that is linear, no isomers are possible. ML3 system, trigonal planar, no isomers are there. ML4 is interesting because tetrahedral is there. Stereoisomer is only possibility R and S. Then same 4, that is MA to B2, square planar structure has cis and trans. Octahedral has two isomers possible, Ma2B4, cis and trans geometrical isomer, Ma3B3 facial meridional isomers. We will see one by one by structure and geometrical possibility. First, we will see what is geometrical isomers. Geometrical isomers have same formula but different arrangement of atoms. Atoms placed in different position. Here I given octahedral. If you look at the white atom, first one it is in the planar form. It is in the plane, that is equatorial. If you look at the second one, white atom in the axis, that is axial form. The different arrangement of atom is called geometrical isomer. This will exhibit in all kind of shapes. We will see one by one. Before getting into the detail, you should know what is shapes, that is fundamental shapes. Linear everyone will know. Linear arrangement of atoms. Trigonal planar mean middle atom connected with three different atoms. Tetrahedral mean atoms placed at the corner. Square planar mean in a plane like square, atoms are placed at the corner. Trigonal bipyramidal mean trigonal structure with above and below atoms. Octahedral means 6 atoms connected in octahedron. So these are all the basic shapes. If you don't understand these shapes, solving problem will be difficult. Better you watch this slide again and again and you should imagine perfectly. First, linear shape. Linear shape don't have any isomers. Ma2 mean connected linear. MAB, that is different atom also connected linear. In linear system, no isomers are possible. Then Ma3 system, that is 3 atom connected with central atom, that is Ma3. Other possibility is Ma2B. AB2 is same because only labeling is different. So only possibility is Ma2B. That also don't have any isomer because all in one plane. If you rotate, you will get same atom. So Ma3 trigonal planar don't have any isomers. Then Ma4 isomer, it has tetrahedral as well as square planar. Here we will see tetrahedral. The possibilities are Ma4, MAB3, Ma2B2, MAB3, Ma3B are same. So only 3 possibilities. Here Ma4 don't have any geometrical isomer. MAB3 also because structure is symmetrical. Then Ma2B2 that also don't have any isomer. So tetrahedral don't have any geometrical isomer. If you draw also, you will get the same structure. Then Ma4 stereoisomer because tetrahedral don't have any geometrical isomer but stereoisomers are possible. For that you have four different atoms connected with tetrahedral. If it is arranged clockwise, it is called R configuration. If it is arranged anti-clockwise, it is called S configuration. Basically, the arrangement of atom. This thing difficult to view 3D way, but you can understand in the plane. This kind of isomer shows optical isomerism. That is, it can rotate the light. So you should know tetrahedral has R and S configuration. That is stereoisomer. Then Ma4 different possibility square planar structure. Tetrahedral no geometrical isomer. Here it has two possibility cis and trans. First we will see Ma4 structure no isomers. Then Ma3b structure planar no isomer. Then it will get interesting when Ma2b2 structure whether the atoms are nearby or atoms are against each other. Atoms are nearby means cis isomer. Atoms are against each other means trans isomer. So square planar structure has cis and trans geometrical isomer. Then we are moving into octahedral, that is Ma6 form. It has four possibility. All other twos are same. Ma6 no isomer. All atoms are same. Ma5b only one type is possible. No geometrical isomer. But Ma4b2 has trans and cis geometrical isomer. Then Ma3b3 which has facial and meridional isomer. So two different sets, two different geometrical isomer we will see shortly. So you should know the fact here is in octahedral system two different types of geometrical isomer is possible. First we will see cis and trans isomer in octahedral. Cis means the atom is nearby. Here I shown B atom. If it is nearby mean it is on the same plane. If it is trans mean it is against each other like it is in axis. Axial B2. So Ma4 B2 shows cis and trans isomerism. Then another geometrical isomer from Ma3b3 formula. Here octahedral have another set of isomer that is facial and meridional. Facial mean three atoms in the same face of octahedron that is on triangle. Another set is it is against each other that is T shape. Facial here I shown the video. If you look at it all atoms are in the same face, that's why it is called facial. Meridional, if you look at it, it is like T shape. A are in T form, B are in T form. It is like connected T. One easy way to identify facial form is atoms will be continuous. In facial, if you look at it, atoms are continuous. That is A, B, B, B. The trick is same. Apply with meridional. Atoms are not continuous. BAB, BAA. So you should know facial and meridional structure. From all the facts, we are going to solve 10 problems because problems are best way to learn. It will give different perspective and complete understanding. Let us see the first question. The complex PT ligands are PY, ammonia, bromine, chlorine will have how many isomers? A 3 isomer, B 4, C 0, D is 2. The answer is 3 because if you draw it, you can clearly understand the answer. If you simplify the complex, it will be MABCD system. All 4 ligands are different. Platinum always has square planar structure that you should know. So square planar, we will fix one atom, draw opposite atom as a variant. A atom is our fixed atom, B is different, then C, then D. So totally 3 isomers are possible. This kind of problems you will only solve when you understand the concept better and clear 3D identification. Then the next example, find the correct structures of trans nickel Br2B BH3 twice and meridional CO cobalt NH3 thrice NO2 3 PQRS 4 structures are given. You should find which represent trans structure as well as meridional structure. Here problems are straightforward once you know the basics. Trans mean you have opposite same atom. Only P has same PR, that is cis, that is trans form. Q, B are adjacent to each other, cis form. Then question is about R and S. R and S, if you look at it, R has continuous NH3, so it is facial because it is in same phase. Meridional, it has discontinuous placement. So S is meridional, P is trans. So our answer is A. The concept you have to know here is trick to identify facial structure is continuous placement of atoms. Then the next example, ClCOCl bond angle values in facial CONH3 thrice Cl3. The angles are A 180, B 190, C 90 and 180, D is 90 and 120. The question is about facial arrangement of cobalt, ammonia and chlorine. The compound in question is simply Ma3B3. If you draw facial form, find the bond angle. You can clearly see all the bond angles are 90. That is bond angle between chlorine, cobalt, chlorine is 90 degree. So answer is B 90 degree. The concept you have to learn here is not only you understand the formula, you should understand 3D imagination of the structure. Then only you can answer the problem very comfortably. Then the next question, the number of geometrical isomer for the complex PTNH3 twice Cl2. The choices are A3, B4, C1, D is 2. Here geometrical isomer is given platinum NH3 Cl2 type. If you draw simply, it is Ma2B2 form. Platinum always form square planar structure. That is very important fact. Then you can draw cis and trans isomer. Cis mean B atom on same side. Trans mean B atoms on opposite side. So two isomers are possible, cis and trans. So our answer is D. The concept you have to learn here is platinum always forms square planar structure. Then the next example, number of geometrical isomer for the complex MABXL, metal is M, hybridization is sp3. Choices are A4, B2, C3, D is 0. The given compound has sp3 hybridization, that is tetrahedral structure. As we know, tetrahedral don't have any geometrical isomerism but has stereoisomerism. Question is about geometrical isomerism. So we don't have any isomer. If you do also, you end up with same. All four different compounds are same. So number of isomers for tetrahedral compound is 0. The concept we have to learn here is tetrahedral compounds has no geometrical isomer but it has stereoisomers. Then the next question, number of optical isomer for the complex Ma2B2 complex with hybridization is sp3 and dsp2. M is metal, A and B are unidentate ligand. The choices are A 2 and 2, B 0 and 1, C 0 and 0, D 0 and 2. The question is tricky. The question is about optical isomer, not geometrical isomer. If you don't read it carefully, you might waste the time. So clearly see optical isomer mean metal attached with four different attachments in tetrahedral structure. Given compound is Ma2B2. sp3 hybridization produce not a different attachment, so it is not optically active. Then same with square planar, that is dsp2. All atoms are same plus it is in plane. Planar compounds don't have any isomerism because of symmetry. So both compounds don't show any optical isomerism. So answer is 0 and 0. The concept you have to learn here is clearly look at the question. The question is about optical isomer or geometrical isomer. Then next question. The complex ions show facial and meridional isomers are A. Cobalt with ammonia thrice, NO2 thrice, and platinum with NH3 twice, Cl2, cobalt with NH3 4 times, Cl2 cation, then cobalt with Cl2Br3 cation. So you should find which one has facial and meridional isomers. The answer will be straightforward if you know facial meridional structure formula, that is Ma3B3. A is our answer because cobalt is M, ammonia and NO2 are A and B, so Ma3B3. But we should eliminate other choices. The B choice is platinum NH3 twice Cl2. Platinum means square planar. It only has cis and trans. C means A4B2 structure, that is cis and trans forms are possible, not meridional. Fourth one is Cl2Bl3 that has only trigonal bipyramidal structure. We need octahedral for facial and meridional. So only possibility is A. The concept you have to learn here is the question may come in the reverse form. If you know the general formula, you know the isomers. Then the next example, the complexes can display geometrical isomerism is R. A is platinum with 3 ammonia and Cl. B. Platinum with 1 ammonia, 5 Cl. C. Platinum with 2 ammonia, 1 Cl, 1 NO2. D. Platinum with 4 ammonia, 1 Cl and 1 Br. You should find which one will show geometrical isomerism. Here, if you know the general formula, you can clearly identify the isomers. First, we will go by the fact platinum always forms square planar. So we can eliminate easily A and B because only one ligand is different. That is A is Ma3B system. No isomers are possible. B is MAB5 system. No isomers are possible. If you look at the C, it has M, A to BC system. So cis and trans type is possible. So that could be our answer. Then D, platinum with 3 different ligand, Ma4BC system. So it can form cis and trans type of structure. So it can form 2 different isomer. So only our answer is C and D because it can have geometrical isomer. The concept you have to learn here is always draw the structure, find the possibility and predict the isomer. Then MABCD tetrahedral geometry can have which one of the following isomerism? A. Geometrical isomerism, B. Optical isomerism, C. Coordination isomerism, D. Both A and C. The answer is optical isomerism because tetrahedral structure is symmetrical. 4 different ligand mean you don't have any geometrical isomer. So only possibility is chirality R and S, that is optical isomerism. The A is not possible geometrical isomerism because both are structurally different. C. Coordination isomerism is not possible because structure is tetrahedral. Only possibility is optical isomerism. The concept you have to learn here is geometrical isomerism not possible in tetrahedral structure. Then the next question, number of geometrical isomer for the complex CO NO2 3 times, NH3 3 times. The choices are A 4, B 0, C 2, D is 3. So you should find possible geometrical isomers. Here, if you write the general formula, you can clearly see facial and meridional. Here, MA3B3 mean facial if you draw all 3 continuous, meridional mean discontinuous or T-shape. So isomers 2 are possible, that is meridional and facial. This kind of problem may look simple once you understand the basics, but always I recommend to write simple formula instead of big ligands. Here, if you see just big complex written as MA3B3, then it will give better clarity, clear understanding, help you to solve the problem better. The concept you have to learn here is facial isomer will have continuous ligands, meridional isomers has T-shaped ligands.